I'm going to just talk about things that are changing in the AI training world and HPC world. All right, something that is changing inside there. But just in case you guys lose me or whatever, I'm going to just start off with my conclusion first, right? The key takeaways. So if you just didn't hear me or forget about what I say later on, just remember these few key takeaways, right? So the first is a lot of the networks, for AI training and for HPC are moving towards Ethernet, right? And one of the things with Ethernet is that it has a long history, 10 megabits all the way to 800 gig today, and then 1.6T coming, right? So along the way, it has a lot of challenges, ATM coming to mind and stuff like that. It beat them all, right? So it survived, right? And along the way, later I'll show you some of the new features that were added, in order to make it what it is today, right? And then in order for you to be able to do all those things that you want to do in AI training, HPC, the performance needs to be tip-top, right? Higher bandwidth, low latency, and stuff like that. All those things are in Ethernet today. And because Ethernet is so widely used, right? There's economy of scale. Every vendor provides such a solution, right? The cost is, CapEx cost is lower most of the time, right? And then you need to operate the network, right? Once you put into your network, you need to operate it. So to operate it, you need people who are skilled to do it, right? So Ethernet, I think, I throw a stone here. I think everybody knows how to operate an Ethernet network, right? So it will also reduce the cost, in your OpEx, right? And in the data center, AI data center, HPC network, you're going to have a lot of ecosystem partners that need to go inside. You need to have servers, the NIC cards, the management systems, automation frameworks, and stuff like that, right? So a lot of those exist, with Ethernet, right? And so it makes it very good for you. If you implement it, right, it's going to have a long runway, and that will keep your investment going, right? So at the end of the day, right, even if you can't remember this 5, just one sentence, right? Ethernet today is a viable, cost-effective solution for your AI training networks and HPC networks. It's a really viable, cost-effective solution, okay? So let's talk about what kind of performance are we looking at, right? So I think if you look at the top 500 supercomputers, right? So along the years, 2018, you have a what we call a InfiniBand, backed summit, right? And then followed by Frontier and El Capitan. They are all HPE Slingshot backed network. So in these networks, you can see that from 2018 to 2024, the bandwidth of the fabric has jumped almost 10 times, right? So it's going to go more, right, as you require more and more performance, right? So how are we going to do that? If you are going to move into a more standards-based solution, right? Because InfiniBand is kind of proprietary. Slingshot is Ethernet-based, but it's more like a Cray modified Ethernet, right? So it's not really standards-based Ethernet. Right? So if you move forward, if you want to have a standards-based Ethernet to be able to do all your tooling and stuff like that, can it be done, right? So actually, it can be done, right? So how it's done is that along the way, there's so much innovation that goes into Ethernet, right? So Ethernet used to be like best effort technology, right? So back in the days when people start to want to run fiber channel, right, over the Ethernet, they typically do it over InfiniBand, right? But some people also wanted to do it over Ethernet. And that's where you have technologies such as priority flow control, PFC, ETS, ECN, and all the stuff that were built for Ethernet, right, in order to cater to the requirements of running fiber channel over Ethernet, right? Fast forward today, when you need to do all the AI training, you are basically doing what we call rocky, right? So RDMA over converged Ethernet, right? So that has a certain set of requirements, right? So latency got to be low, you got to be lossless, you know, and because of the network, usually it's a cloud-based network. You have a packet spraying. You need to have additional capabilities such as intelligent load balancing, right? So all these are actually built into Ethernet today, right? So this is basically, you know, something that basically helps Ethernet, you know, to make sure that, you know, in this kind of network, it actually can perform, right? So if you want to make sure that it can perform, right? So one of the best ways, okay, is to actually test it out, right? Run it. So there's this thing called a website, you know, ML Commons community, where they provide a certain set of data sets, different type of data sets, right? So you can take those data sets and then do the training, okay, inside your network. All right, so this is a third-party WWT. Though they did some testing with the network switch. Basically, basically both InfiniBand switch and Ethernet switch are being tested, right? And you can see that the performance, right, at the end of the day, it's not much difference, right? So if you take the the inference as well as the training, you know, Ethernet and InfiniBand, the performance, it's almost the same, right? Not much difference, right? So if you want to compare more, right? So this is simple, maybe a one switch test. If you want to do a more like, you know, actual cloud, 2 spine, 4 switches, or even a bigger network, you go to ML Commons, right? So all these vendors, when they do the test, they will actually upload all the results, and you can compare, right? You can just pick and choose, see which one you want to compare. So those are the results. You can do a compare and see, you know, whether the results make sense, right? And you'll see that, you know, the results between similar setup, right, between InfiniBand and Ethernet is roughly the same, right? So for training, job completion time is about the same. For inference, time to first token, sustained token rate, and all those things are about the same, right? So now the performance is about the same. You know, what about the cost, right? We talk about trying to be a cost-effective solution, right? So then you'll see that, you know, this is something that Aotearoa has done some studies, right? Basically, the cost per port of Ethernet is cheaper, right, than InfiniBand, and in some cases, you know, can be like 1/3 cheaper, right? Sometimes it can be half, right? It depends. So if you look at it, you know, one port is this amount. No, if you have like hundreds or thousands of ports, you're going to save quite a fair bit of the cost. And this is basically something that is going to help you, all right, save the cost, and you can use it somewhere else, right? You know, in your research, get a bigger network, and all the stuff, right? And the cost goes down. This is just the network, right? And then, like I mentioned just now, you're going to have a set of ecosystem players that needs to go into that network. So basically, you know, you have like servers with the whatever GPU, TPU, NPU, you know, CPU, whatever, and then you got to have the NIC cards, the NICs. The NICs is going to be connected to optics or cables, right? Goes to the network switches, and then you need to have the switch, and then you have to have all the automation frameworks around, you know, to automate everything. So this, you can see that, you know, if you are going to go with the Ethernet, you have a lot of options, right? So many options. But if you go with InfiniBand, it's probably going to look like this, right? everything NVIDIA, right? Maybe on the tooling side, you know, you can have a bit more, but by and large, it's going to be NVIDIA, right? So this is something that is going to be problematic moving forward, because you're going to get trapped in one single vendor, right? And with InfiniBand, like I mentioned just now, you know, you're going to have much less people who knows how to really operate InfiniBand, right? So if you have a problem, troubleshooting is going to take longer because you got to go back to NVIDIA to help you to do the troubleshooting, right? And in order for NVIDIA to help you, you've got to buy their services, which is not cheap. Right? So you're going to get stuck in the loop of an expensive solution, right? And because they are the only one, I don't think they have much incentive to innovate. Right? So you're going to stuck at this level when Ethernet is going to go much further because there are so many players out there that's going to add a lot of innovations, okay, to Ethernet, right? And if you look at what's happening today, the shipping, right, for InfiniBand for AI backends, right, is already less than Ethernet. Ethernet has already overtaken. The inflection point has already happened, right? And there are some of those hyperscalers, like for example, Meta, they have a cluster that's actually Ethernet-based for their training. So they are also slowly moving away from InfiniBand, right, into Ethernet, right? And if you look at the top 500, right, if you go to top500.org, you download the list and then you check, which are the ones that are Ethernet-based. Almost, I think about 30% is Ethernet-based, right? So Slingshot is Ethernet-based. It's classified as Ethernet-based. So if you remove Slingshot, it's still about 20% is Ethernet-based, right? So it's growing, right? And so if you look at it, it have all these advantages, right? Which I did mention just now. Right? So that's essentially something that Ethernet is capable of, right? To help you to reduce all this costs, right? And so with this is what is capable of today, right? So today's Ethernet is already able to do this with all the additional features and functionalities, right? So where does UEC come from? Come into play, right? So Ultra Ethernet. So that is something that is already here today. A lot of the switch chips already supports it, right? So they already support the chip. The chip already support UEC, but most of the vendors you'll see that it's not really a GA feature yet, right? But for Nokia, we have shown, right, last quarter, Q4 of last year, that we have some beta code that we use to test to show the world that we're actually compliant, okay, with Ultra Ethernet transport, right? So some of those features and functionalities are already there. But today, if you want to implement it, right, you can, right? Because if you look at the Ultra Ethernet stack, right, there are optional items and mandatory items, right? So the mandatory items are on the NICs, right, on the NICs. Yeah. So most of the optional items are actually on the network side, right? So today, if you want to implement UEC, you can, because you can get NICs that already support UEC, right, and running over existing Ethernet network that supports lossless Ethernet, right? You will get the good results, right? And moving forward, when the switch vendor supports UEC, a new software upgrade, you will get the function. Right, provided that the hardware is UEC ready, right? So if you have a UEC ready switch there, right, it's just a software upgrade, right? And so for us, Nokia, we provide inside the data center, the whole thing, right? So we have the switches, right? So the newer switches are UEC compliant. They are ready already, right? It's just the software is not there. And then, of course, in order to run that, you need a very reliable, open network OS. So that's where the SR Linux comes into the picture. And to make sure that you are able to automate, you're able to orchestrate the entire network from day 0 to day 2 operations, right? When you have so many of these switches, you need a very good intent-based automation system, right? That's where EDA comes into the picture, right? So at the end of the day, right, today I just want to repeat the one sentence again. Ethernet, right, is becoming a real alternative, right, to using InfiniBand inside HPC networks or AI training networks. And it is a cost-effective alternative. Okay, that's all. Any questions?
What are the deployment challenges, come from the HPC world where InfiniBand is common, but ultimately we're just about to deploy? Well, we're doing roughly V2, so we're doing high-performing Ethernet.
Yeah.
So what are the biggest challenges?
So Yeah, integration is usually the challenge, right? So you have the different NIC cards. The NIC cards, because usually the switch vendor don't provide a NIC card, so you have to make sure that they align properly, right? And then of course all the software versions, the firmware versions on the server side and on the switch side, they match up. So these are most of the time. So because Nokia, we have a lab in Sunnyvale that we actually have AMD GPUs, NVIDIA GPUs. So we do all these tests, right? So these are some of the things that we see that are most problematic, the matching up between the different vendors, right? And another part is also how to tune. So, I talk about ECN and all stuff, right? At the end of the day, it's just you have to tune the buffer settings and stuff like that, right? When EFC come in, kick in and stuff like that. So those are the tunings that you may have to do a little bit of testing, right, to see the results, right? But at the end of the day, once you finish the tuning and you make sure the firmware while working is generally okay. But that part probably take a little bit of time. Yeah.
You may have time for one more question. Great.
Okay.
I'll ask one.
Yes.
And I was just wondering, the comparison, it was an impressive talk.
Okay,
interesting
thank you.
results of what can be achieved with Ethernet. Now, where we are comparing performance InfiniBand versus Ethernet on the AI workload, has there been comparison also on other workloads which would be more traditional HPC, demanding lower latency?
Yeah.
How does that pan out?
Yeah, so we do have, we don't have the results here, but we do have a customer, a university, who has deployed this together with one of our server vendor partner, right? So they have deployed in one of the HPC clusters. It's actually one of the top 200, right? But I can't say who is it, but it's one of the top 200, right? Yeah. So they will be doing some tests moving forward, to show some results. Yeah. But the initial testing is like it. I mean, I'm not from HPC world, but then I say it looks good, right? But moving forward, they will provide more figures, in terms of the testing and stuff like that, right? Yeah. Okay. But that is one of the number 100 something. Yeah, I can't tell who, but it's 100 something. Okay. Yeah. Okay. Thank you.
So please, one more round of applause for Kuangbin.
Hi, I'm Dan Mons, CTO of Sharon AI. I'll get into what Sharon itself does in a little bit, but a background on me specifically. My background prior to Sharon was in research and HPC. I came from that industry, working with government and a few private industries as well for a lot of years. So fairly deeply embedded in the HPC research communities for a long time. Prior to that, worked in visual effects, which is very similar to HPC. You just make pretty pictures that are less important, I guess, than HPC. So a lot of those worlds combining in the modern AI world, and a lot of things that sort of combine into some of my passions. Digital preservation is one, and I heard a fantastic presentation yesterday in the keynote. I'll talk a little bit about that as well, what that has to do with all of it. But in particular, I hate buzzwords. So I'm not going to do any buzzwords, or if I do, I'll make sure I turn them into plain English, because that bothers me. So buzzword number one, sovereign. Cool. I think I see this on everything, everywhere. It's one of those questions of what does it even mean? In Australian markets, it tends to be a bit of a tick box item. I find here in New Zealand, you do a much, much better job of actually caring about it and making it an important thing. But I think it's a really sort of multifaceted thing. So I like to talk about that a little bit. And the way I like to talk about that is one of my favorite sort of parables, proverbs that talks about perspective. And it's the blind men and the elephant, or the blind monks and the elephant, parable that came out of India about 3,000 years ago. And it goes like this. An elephant is there, some blind monks all get around the elephant and they try and get their perspective on what this thing is. One grabs the trunk and says, oh, that's a snake, and one grabs the ear and says it's a fan, one grabs a leg and says it's a tree, the side of the elephant a wall, the tail of the elephant a rope, and the tusk of the elephant the spear. So the question is, who's right who's got the right perspective, who's actually understanding what this problem is. Well, they're all kind of right? It all kind of matters. It all depends on how you look at a problem. And I think the sovereignty problem is a very similar kind of issue. So I don't think this is the complete answer to what sovereignty is. I think this is my part of the elephant. When I talk to customers, I often hear their part of the elephant, which is very interesting to me as trying to solve the particular issues around high performance compute that have nothing to do with the performance and everything else that is vitally important. So to me, and I think to a lot of people at a very shallow level, sovereignty is where your data lives, right? It's got to be in this location, or it's got to be in this country, or whatever. I think that's missing the bigger picture of what sovereignty is around data. I think there's a lot of other issues that come into play, and they don't probably get thought about early enough in the picture when we try and scope a lot of these solutions that we build. So who has access to your data? So again, just because it's secure and it's in a secure location, how do we prove who does or does not have access to that? How do we make sure that prying eyes stay out of it? How do we ensure that the vendor who's putting it in doesn't have access to it? There are all sorts of valid questions, I feel. How much control do you have as the owner of that data? Can you take your data out at any time? Can you validate it with whatever compliance requirements you have, or community requirements that you have, or any of those sorts of things? I think that's pretty critical. How much visibility you have over it. So not just logging and security and SIEM and those sorts of things, but can you prove to a certain point the full path in and out of that data, and that there's nothing in between that's looking at it? But also, what's happening to it, who's accessing it, when are they accessing it? Those sorts of access logs, I think, are pretty critical. Outside of just data itself, I think where you employ your people and how you give back to your community, for me personally, are sovereign issues. I think that should be a part of the high performance compute talk when we talk about this sort of stuff. And again, what I really love about coming here is that is front and center, and all of the talks that I've listened to over the last couple of days, which I really love. I find it quite challenging in Australia because it doesn't seem to be as high on the list, so kudos to you guys. So how do we achieve sovereignty? Assuming that we have this picture of the elephant, how do we kind of get to our view of what that is? I think traditionally when people go and scope solutions to any sort of high performance problem, they have two options. Option number one is on-prem. Put it in my data center, lock it down, I'm in control. Cool, but a whole bunch of challenges that come with that. Do you have the people to do that? Do you have the power to do that? It takes a lot of energy to drive this new stuff. And we're finding a lot of customers are attempting to do the on-prem thing, and the first thing they do is run out of power before anything else. Number three, it's a lot of capital up front. You have to put a lot of money in to buy this stuff and put it in place, and that makes taking a lot of that research grant money and whacking into this stuff day one. I think that's really challenging. Option two then becomes cloud, shove it in cloud. I think that's great. That's a great option. But again, the sovereignty questions start to come in. Do the cloud players that you want to partner with have the equipment here in country, or whatever your sovereignty requirements are? Do they have the performance that you require? Often cloud, there's some sort of performance trade-off compared to doing it on-prem. And a whole bunch of other questions that sort of come with that. So I think it's a valid option. I just think it's missing a few things. I guess the crying shame of all of this is not that either one of those are bad. They're perfectly good options, but it would just be lovely to have an option three, I think. More options are good for everybody. Makes things a lot better. So new buzzword, if you like a bit of buzzword bingo, I do. I play it at meetings all the time. I get a lot of trouble for it. Neo-cloud is the new buzzword. What is a neo-cloud? Well, Sharon AI is a neo-cloud. So let me explain just quickly what a neo-cloud is. Number one, it looks like cloud, which is kind of cool. So all the things you expect out of cloud, right? You want things to be API driven, and you want things to be programmatic, and you want things to be dynamic. You want people to either hit it through code or click buttons and things spawn up. You want to give a lot of control to not just your technical sort of sysadmin-y programmer-y people, but you also want to give a lot of control to your scientists and your researchers. You want them to be able to interact with this stuff really easily. Traditional models of HPC, your Slurms and your PBSs and those sorts of things. I've spent a lot of time working with those in my career. They're great, but this new way of doing things can be a lot friendlier and sort of lower that barrier to entry to get good scientists doing good science quickly, which I think is as critical as anything else. On the flip side, neoclouds are built like HPC, and I'll go into the technical details a little bit, not too much because I don't have a lot of time, but that's important. I think HPC is a concept. You can't get away from the idea that there is compute separate to network, separate to storage, separate to everything else. HPC really needs to be thought of as a cohesive thing, and the performance profiles of how that work are very important. I think they're quite critical. So the idea of taking what was traditional HPC that we kind of shove in the basement, don't put anywhere near the internet, and then trying to securely put that on the cloud, but then give you a bit of control, is kind of cool. Choose your tools, load whatever you want. I think, again, the cloud vendors do a great job of providing a fairly large suite of tools. I can think of a couple in particular who just have a massive amount of choice. I still think, though, you're a little bit locked into kind of their ecosystem of what you want to do. Certainly with Sharon and a lot of other neoclouds that are in our space, there's a lot of choice. You can bring your own existing work sets and put them on us. There's a lot of that sort of those issues of how do we cloud migrate from on-prem out to cloud. NeoCloud gives you a lot more control, a lot more options around that. Bring your own tools if you don't like our tools, although we have a lot of tools, which I'll show you in a sec. Take control and be sovereign. So again, all those points that I made before about why sovereignty matters and what sovereignty even is, I think the NeoCloud path bridges that gap a little bit more between the on-prem and the cloud options, which is pretty cool. So who are Sharon? Sharon AI is it's an NCP, so NCP, NVIDIA Cloud Partner. NVIDIA themselves, quite realistically, could have been the next Amazon or the next Azure. They could have done this themselves, built these cloud options themselves. I think what they've done instead is very, very clever. NVIDIA understand that local organizations have better local knowledge and they understand the local markets. So NVIDIA go a long way to empowering companies like Sharon, and we're not the only one. There's plenty of neoclouds out there. There's neoclouds in other regions, in the US and Europe. NVIDIA go a long way to empowering us to use their technology, but then understand the local markets. So we can build that local connection with the customers, whoever they are, whether they're government, whether they're research, whether they're education, whether they're private sector. And even within the neocloud space, you'll find a lot of neoclouds who then specialize within those industries, right? They'll do a better job of this kind of customer versus that kind of customer. So the whole thing sort of ties together with NVIDIA. The NVIDIA Cloud Partner Program as well has a very specific requirement when it comes to reference architecture, design, and performance. NVIDIA have been doing a lot in the HPC space for a long time, so this whole cloud thing for them is very much taking that HPC performance, putting it in the cloud like I spoke to before. And of course we have a lot of partners. Sharon does not provide hardware, we provide hardware from all of our partners. We have many, many partners around the place who help us with different parts of the clusters, the data centers, the power, the cooling, the people, all those sorts of things. We are definitely not an island and we work together with all of these folks, some of who are in the room. I mentioned a little before about visibility, making sure that you can see what things do. This is just an example. This is our vast storage. These are the sorts of things that normally you wouldn't see if you were sitting out behind some sort of pane of glassy, cloudy kind of thing. We give these to our customers. If they want access and they want to see what's actually going on right down at the hood and they want to get deep into the infrastructure layer, absolutely they can. This is just a cool kind of VAST doing its multi-VIP, multi-threading thing to give its hugely parallel performance, which is lovely. And again, within this we can do a whole bunch of multi-tenancy, making sure that's secure. I'll show you a bit of the authentication stuff in a moment to make sure that that's all happening securely. And again, if you want that visibility, great. If you don't want that visibility, don't have to have it. Again, that choice is yours, giving you a lot more flexibility. This is really cool. This was our vast storage that we did some testing on. So single node got us to half a terabit a second. Dual node got us to a terabit a second back and forth out of our vast storage. So again, emphasizing that HPC performance. Something that can be challenging when you're doing it yourself, if you don't have the infrastructure to roll that out in the first place for the sort of capacity that you need, or if you're going out to cloud, those sorts of things outside of the compute can be very difficult to achieve. There is nothing worse than an idle GPU. You want to make sure you're pushing stuff into that GPU at scale, making sure you've got the nice fast storage sitting behind it, that it's architected in the right way, that it meets the reference architecture. It's all very, very important. I apologise to the previous speaker. This is our InfiniBand network, although we can do Ethernet as well. Every single GPU is in a non-blocking configuration, leaf and spine to every other GPU, 400 gigabit InfiniBand in our current Melbourne cluster, B200 cluster. So yeah, 1,016 GPUs that all have nice speedy access to each other if you need to do your MPI jobs, if you need to do your RDMA stuff. And again, this is all courtesy of the NVIDIA reference architecture, right? So this is all part of this NVIDIA Cloud Partner design. NVIDIA are very stringent on how this is designed, how it goes together, minimum throughput, minimum results. So anybody who falls under the NVIDIA Cloud Partner banner has to ensure that we meet this architecture reference and that we meet the performance. So switching gears for a little bit, back to kind of the sovereignty thing, where is Sharon? We're kind of all over the place. We have compute in Sydney and Melbourne. We have people in Sydney and Melbourne as well. We have some staff in South Australia. I'm from Brisbane. One of our directors is from the Gold Coast. All three of our founders and our CEO are all from Sydney. So we're very much an Australian company, really focused on the Australian market, really focused on the Australian research market, which I'll go into in a little bit. Where we are not is New Zealand, unfortunately, but we're trying very hard. So watch this space. That would be cool. Again, the sovereignty angle. If you want to authenticate on our stuff via whatever SSO, SAML, OIDC, federated thing that you've got, we can do that. This is the login page for our public cloud. Our public cloud is not sort of what we would give to larger customers. It's a bit of a playground that people can jump on. There's some social sign-ons things. You can sign on with your Hugging Face and your GitHub and whatever. But all of this gets customized for customers if they want. So if they come in with a federated Microsoft 365 thing, if you want to use the Tuakiri REANNZ authentication, if you want to use Australian Access Federation federated identity, anything in that kind of space, we can customize that. And again, all those roles will feed right through. So if you define people in your organization based on roles, we can map those roles into our infrastructure. And again, that's kind of that neo-cloud difference, right? We can really modify our stuff to work with your stuff so that it feels like your stuff. Once you're in the user interface, again, this is one option, right? You don't have to use this. If you don't want to use this and you want to roll out traditional Slurm or you want to do some Kube or whatever, go for it. This is our interface that we provide as sort of a bit of a default. It comes with this, everything's kind of Kube driven in the background except for the VMs. They deploy a little bit differently, but it lets you do whatever you want to do. You can spawn virtual machines, you can spawn pre-baked notebooks. I'll show you a notebook interface in a sec. Developer pods are really nice, so bring a container along and deploy it and see what it does. Pre-baked inference endpoints for different inference engines, OLAMA and VLLM. All of this really goes down to that giving scientists control, giving them the ability to launch things quickly. Again, my background in HPC, I did thousands and thousands of hours of training over the years for people. I think one of the worst things ever that I saw in the, especially in the Australian government market, was they would buy a lot of very expensive tin and hand it to a scientist and go make research, and the poor scientist was kind of left stranded. So as much as training is critically important, we do everything we can to try and bridge that gap. The simpler the software, everything that you can one click to spawn something, I think is critical. And not just spawn and drop into some developer tools, but in some actual useful environments, I think is really lovely. What's coming too, we don't have this up yet, but there's a full managed Kubernetes stack, so you can have an entire managed Kubernetes environment if you want. We're working with a customer at the moment where they have their own managed Kubernetes elsewhere and they want to use us as endpoints for that, so we're working on how we deliver that. I'll show you a bit of API stuff in a sec. If you go into one of these, for example, click on one of the notebooks, we can pre-bake a bunch of stuff in there. So if you want to define some environments, TensorFlows and PyTorches and NVIDIA Rapids, so all the NVIDIA AI Enterprise stuff that they've got through their portal with all their pre-baked, pre-optimized containers and runtimes and all the really cool stuff that they've got, or you can go open source, whatever you want. We can populate this for you, or we can give you control. You can have the templates, you can do it yourself, you can get under the hood, do whatever you like. Again, you define, we'll go, don't have to use this, can use this if you want. Everything's API driven as well, so whatever you can do through the GUI clicky, you can do through an API endpoint call. Anything that you spawn in here will spawn API endpoints, so it'll give you the endpoint for that, set up all the HTTPS, blah, 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 so you don't have to play sysadmin and do all that annoying stuff, give you your access tokens and things. Again, makes that whole concept of deploying something quickly and using something quickly and putting the power in the hands of the people who are running it really good. How you multi-tenant this up is up to you. You can either have your admins do this bit and your scientists use it, or you can give this to your scientists. Again, the control is yours. That's the sovereignty point for me, how much control you have and how much you want to do with this. We should not tell you how to suck eggs. And then observability, right? So you've got to be able to see what's going on. Because this is all kube-driven under the hood, there's a whole bunch of observability stats that you can get. Whether you want to give these to your scientists directly so they can see the efficiency of the jobs, whether you want to give that to your IT people so that they can see how these things are being put together, internal accounting, who's using what when and how do I charge back, and all those sorts of important questions for your finance people. Security people can hook in. They can plug seams and XDRs and logging and all sorts of cool stuff into this so that you get that visibility. Again, I think that is all part of the sovereignty solution for me. You should be able to see whatever you want to see whenever you want to see it. I think that's pretty critical. That is your part of the elephant. So that's all cool in theory. Has anybody actually used this to do anything cool? Yes, there's been some great outcomes over the last 6 months or so. We work closely with University of New South Wales. We also work closely with USyd and UTS, but there's a whole bunch of research that got done in a big batch out of UNSW recently. My favourite was this one, maybe a bit personally. One of the researchers, PhD student, worked with SmartSat to do some accelerated global weather forecasting, and again, it's something I have done in a previous career. Fascinating stuff where one PhD student with access to a whole bunch of GPUs did a bunch of modeling using some sort of pre-tweaked and then retrained LLMs and got some really accurate results that came out 4 or 5 times faster than existing kind of traditional work that SmartSat was using as part of their kind of recommended go-to. So really quick turnaround on the research, really positive result, really easy for the researcher to be able to do it through some very simple interfaces. I think that was a really big win, quite lovely outcome. And again, for me personally, giving back to the community, I think is pretty critical. I think that's something that's a responsibility of anybody in this field, especially when it comes to AI and sort of the impacts it's having on the world. So a couple of things we've done recently. We sponsored a Women in HPC event at eResearch in Brisbane, which was lovely. And we're doing an AI hackathon. This is something that again, part of my training background that I find critical, making sure the scientists know how to use these tools. I just sort of dump them in the deep end and hope for the best. So we're running that next month between ourselves and NVIDIA, who are very generously giving us a lot of mentors to do the training and a whole bunch of groups who are going to benefit from that training. Which is lovely. So thank you very much. That's Sharon, and that's Sovereign Computing.
Thank you very much. We are somewhat tight on time, so I think I'll ask Ron to start his talk now,
Sure.
And we might leave questions to the end, or you can find them around. Thank you. And Ron now takes over with building small-scale trusted research environments. Over to you. Thanks.
Thank you. Hi, I'm Ron Bosworth with Xenon Systems, here to talk about building small-scale trusted research environments. We'll start with asking the question, what is a trusted research environment? We'll take a look at where trusted research environments come from, and then we'll review some approaches for establishing one in an organization. So what exactly is a trusted research environment? Based on my experience, it's a carefully managed computing environment that enables researchers to use specific software to securely access and process data, with the key elements being a user-accessible computing environment configured with appropriate software and tools, user access controls to ensure only the right people have access to the computing environment, and data access controls to ensure only the right systems and users have access to their relevant data sets. In addition, there are two more elements that I feel are worth including because of how useful they are for establishing and maintaining a TRE. There's the data lifecycle management to ensure project data is properly curated through its lifecycle, and a reproducible computing environment, which enables rollbacks in case something goes wrong and allows the user to return to earlier versions of the data processing software in case newer versions change the output in unexpected ways or don't support older data formats. The term trusted research environment started showing up on the internet over the last few years, but there are a few other ways that people label the same kind of idea, such as secure data environment, secure access environment, secure research environment, and you get the idea. There are also a 5 safes framework that's referred to by several groups who have written about implementing these environments. The 5 safes framework focuses on how to manage the risks associated with processing sensitive data in a way that protects privacy while maximising research value. The framework was initially published by the UK Office for National Statistics in 2003 as the Virtual Microdata Laboratory Security Model. When it comes to what shape these trusted research environments can take, we can look to the major cloud providers for some examples. Here's a scalable architecture published by Amazon. You can see some key elements. Researchers, very important. Various controls and governance across different aspects of the environment. Specific mapping of data sets to projects. And even some specialized software and code pipelines. AWS even has an implementation diagram breakout of the various services. Okay, so lots of parts here, definitely geared towards the larger and more scalable side of things. If you squint, you can see a user environment, access controls, data sources, data pipelines. Here's an architecture diagram provided by Azure. While there's a notable lack of researcher icons present, we can still see data pipelines and workflows, controlled data ingest, and specific mapping of data sets to projects. We can also see the computing environments configured with different tool sets. In Azure's breakout diagram, we can see user environment, access controls, and indications of how this system could scale. The core elements are there, along with several optional components to help with scaling and monitoring. Taking a closer look at the 5 safes framework, we can see it's taking a wider view of the system. To expand on each of the elements, we've got safe projects. Is the data being used ethically and for public benefit? Safe people, are the users trustworthy, trained and authorized? Safe data, has the data been anonymized? Safe settings, is the computing environment secure, preventing unauthorized access and data exfiltration? Safe outputs, have the results been reviewed to confirm no identifiable information is published? All good points worth considering, depending on your TRE's purpose. For a small on-premise trusted research environment, the architecture could look something like this. Here we have a data source, perhaps an instrument writing to a specific project folder. There's a user environment configured with specific software. Perhaps the user environment can be virtualized to make snapshots and environment reproducibility easier to manage. We'll need to implement user access controls across each system, so some kind of user and role management system will be required. We could also implement some basic data security. Perhaps the user environment can have read-only access to the project's raw data directory and write access to the project's processed data directory. So where do trusted research environments come from? Ideally, your organisation recognises the value in creating a TRE. If that's the case, then the TRE project can be driven by leadership coordinating between the research, governance, project, finance and IT groups. Though, if your organisation doesn't already have a TRE, it might not be obvious to everyone involved that one is required. If that is the case, you may see a trusted research environment organically form in the wild. Based on my experience, this usually begins with the researcher, triggered by a change in requirements, such as change in the data source, such as planning for a new instrument or data source to come online, new data processing software. Perhaps data processing has outgrown easily available compute, which is sometimes just local workstations. There could be a requirement to develop and run unsigned code, not something most corporate IT standard operating environments are geared for. Perhaps a change of team dynamic or a requirement to collaborate with external users. In its early stages, the TRE may face friction as requirements are presented to the various stakeholders involved. I've found one approach that helps is to take people along for the journey. Help people see how the success of this project aligns with the goals of the organisation and their team. Work with stakeholders at a leadership level to find agreement on the project's vision and collaborate with them to build out a roadmap. What details do people need from you to help make this project a success? Do storage and compute systems require additional capacity? How can these requirements be modelled? Do policies need to change to support unusual software and enable external collaboration? Is a change in workflow required to scale beyond local workstation processing to a larger computing environment? Even when a basic trusted research environment is established, without appropriate ongoing support, it may not be able to adapt and survive. Plan to onboard ongoing resources and establish funding to provide support into the future. Does your organisation like to plan things 5 years out, perhaps 10? These costs should be modelled so there are no surprises down the road. Now you may be asking yourself, how can we avoid the too hard basket? It depends on your organisation's business process maturity. Perhaps you have existing frameworks in place in your organisation that you can use. Within the research team, there may be some experience with similar changes. How are projects approved and prioritised? How is funding allocated? Talk with people involved in previous projects. Find out what worked well and what could be improved upon in the next time. Do you have a governance and project team? Find out what they would like to know, how they would like to be involved, and start to build out a roadmap with them. For the first phase of the project, aim to establish a minimum viable product. Don't let perfect be the enemy of good. Aim to make incremental improvements in subsequent phases. The finance team love expenditure forecasts. The more accurate, the better. They will probably have feelings about the level of detail they require and how far into the future they like to plan. Close collaboration with the IT team will be critical to the success of the project. An IT team who is enthusiastic to support the research will need to understand the requirements from an IT perspective. Things like data generation rates, data storage over time, estimated compute and RAM requirements for a typical worst-case scenario. On the other hand, some teams find embedding specialist IT scientific resources can help align IT support with scientific IT requirements. While there will be technical implementation challenges in establishing a TRE, building the business case for IT resourcing to support both the initial implementation and ongoing maintenance may actually be the greater challenge. There will be questions about the compute and storage required, not just initially, but also projected into the future. This information could be defined using tools such as compute and data storage policies. You can use data policies to define the life cycle and different categories of data, including information about data storage compliance obligations and when data may be deleted. Specifics around the size of the data will be useful to include to help with data storage capacity planning. If you have any known increases expected in the future due to new instruments or data sources, be sure to add them too. The policy can be owned by the research team and should be seen as a business rather than a technical document. Combined with historical and projected data storage utilisation, you can build a model that feeds into a data storage capacity plan. The storage capacity plan can be owned by the IT team, where the planned capacity is a flow-on effect of enabling the data policy. This chart shows data storage requirements projected into the future including a reserve to mitigate the risk of underestimation. You can also see a planned expansion every second year, represented by the dotted line. A similar kind of policy and capacity plan can be created for compute resources too. In summary, I recommend starting with the business case, aiming for a minimum viable product and highlighting how the project aligns with the organisation and the team. Reach out to your stakeholders, anyone who can recognise the value of a project and is interested in seeing this project succeed. Find out how they would like to be involved and what they need from you. A phased implementation roadmap can help everyone pull in the same direction. Include an outline of future phases to highlight the fact that this is a living project requiring maintenance and support to keep up with the ever-changing requirements of research into the future. Take ownership of and create compute and data storage policies if they don't exist. Contribute to them if they do. They will help ensure the services provided by IT align with research requirements. I hope this talk has been helpful. Thank you for your time.
Thank you. Any questions? Yes.
So just wondering whether, as you guys at Xenon offer solutions for the design, management, and deployment of TREs?
Yes. Absolutely. So we cover the whole range from the services and consulting piece to help people figure out what they need. That's where a lot of the policy stuff comes from. It's trying to understand, sometimes from fairly low in the organisation, how to get an initiative up off the ground. They know they need compute, but they don't know how to convince internally their business that they need compute. So it's a bit of that, all the way to providing hardware, software solutions, full vertical stacks that can be brought in to match and integrate with basically anything. Along with ongoing services to maintain and just keep these systems operating into the future as well.
Any other questions? Any other questions for Dan, who I had to cut short? In that case, you get to arrive to the afternoon tea on time. Thank you all for being here.
Wonderful. Thank you.